Welcome on this side area of the EU Digital Ocean Pavilion here at UNOC 2025. This is provided by the EU programs Copernicus Marine Service and EMODnet services. They are the basis of the EU Digital Twin of the Ocean. The EU Digital Twin of the Ocean is composed by the huge amount of data on one side and computational resources on the other side, and ad hoc environments to develop new simulations, new processes in order to produce simulations, what-if scenarios, applications, very useful to bridge a gap between society and science for policy. So let me explain you what is a digital twin of the ocean. Everything starts with observing systems to monitor the ocean. So we need satellites, we need in situ data. This is the fruit of international collaborations to have all these measurements at sea. And then, once we have that, we are able to produce 3D numerical models, which are able to give us the state of the ocean from the surface to the bottom with different variables, which can be for monitoring the physical state of the ocean, temperature, salinity, currents, the biogeochemical state of the ocean with chlorophyll, nutrients, oxygen, and sea ice, and also waves. So you have this information at the global scale and for the EU regional seas. Thanks to the Copernicus Marine Service, we are able to display all the data on a viewer and access all these data. We can start to discover the data, as I said, from the surface to the bottom in the blue ocean with sea surface water velocity. You can have chlorophyll on seawater, sea ice fraction on the polar region. And what can be important for people who are working on the ocean and topic related to the ocean is to add new data from the Copernicus Marine Service and EMODnet services, additional layers like marine protected areas or economic zone. So we can start to play with the data, focusing on a topic with additional information. This is completely feasible on the EU Digital Twin of the Ocean. So you can start to play with the data, exploit data, and create your own process in order to make new added value products. And you can start to share your processes, your services, and the data with other members of this marine community. So you can develop many what-if scenarios or applications related to your topic of interest. And again, this is a perfect tool to help authorities to make better decisions. For example, we start with plastic pollution, and we can make this demonstration for any kind of pollution, in fact. On the digital twin of the ocean, you are able to make new simulation, for example, drift of the plastic on the global ocean. Once you have these simulations over 2 years, you can play different scenarios to see where the plastic will go. So let's start the simulation. I choose a location near Nice, and we will see the plastic drifting in the Mediterranean Sea. This simulation is initiated with an estimation of plastic from the coastal and the rivers. And each particle of this virtual plastic represents this information, the weight of plastic from the rivers or the coast. Because we're working with simulations, and this time we see forward, we can play backward and identify the sources, the origin of the plastic in the region for this particular case in Nice. So let's play backward, and you can identify easily where the plastic comes from. You can go further, playing with a reduction scenario. You choose the emitter of the plastic, the region, and you can play with coastal and river rate of plastic, and you can decrease or increase the quantity of plastic. What is interesting here, two key messages with this kind of application. The first one is that the EU Digital Twin of the Ocean is the perfect place to develop this kind of simulation on this topic, pollution plastic, plastic pollution, or oil spill, etc. and you can easily replicate on other region, other topic. The second key message on plastic, wherever you are, this is a global problem, okay, plastic pollution. And if you want to tackle this challenge, you need to have a global mobilization. Let's see now a second application, what if scenario application. Now we are in the Pacific Ocean. We will launch a simulation of leatherback juvenile turtles from Costa Rica on the nesting beach of Playa Grande. And we know that the behavior of these turtles is driven by the need of food, water velocity, and temperature of the water. So we can play the simulation and see that quickly the juvenile turtles are trapped in an eddy in the Pacific Ocean. You can see also the economic zone and the marine protected areas. Once we have this kind of simulations, it's very easy to make map of density of turtles. And if we combine this information to density of fishing boats, we are able to produce a map of risk of bycatch of turtles in the Pacific Ocean, in this region in particular. And the scenario we propose on this application is to give the authority this kind of tool and see, for example, if they close fishing activity during certain months, and as you can see on the image, I can reduce the risk of bycatch of turtle rapidly. There are many threats for the ocean. We talk about sea level rise, climate change, rise of the temperature, coastal risk for the population who are living near the coast. Now we are in the Wadden Sea in Germany. We will play with this simulation on the reintroduction of seagrass meadows in the Wadden Sea in order to reduce the risk of erosion on the coast. As you can see, we can play with different configuration and parameters and launch a scenario. And beyond this scenario, there is a very powerful model, coastal model, taking into account the bathymetry of the coast, the hydrological conditions, and the sea conditions. And we can play a scenario in case of extreme event to see if we can reduce coastal erosion. So let's try to configure the parameters. For example, I will take an upper porous position for the seagrass meadows with a low density. I place the scenario. And I can see now in the blue areas where I finally reduced the risk of this erosion. But what is interesting in the digital twin of the ocean and this kind of application is that it's very easy to play a new scenario. Let's compare with the new configurations. Now I will take a lower position and a higher density. Now it's easy for me to compare the two scenarios. And I see that I have a better benefits, a higher benefits with the second scenario and the second configuration. This is very helpful for authorities who can manage and have to take decision for this kind of challenge. And you can imagine many scenarios. This is just the beginning. Artificial intelligence and cutting-edge tools are at the heart of this platform. The EU Digital Twin Ocean empowers governments, researchers, and citizens alike to understand, explore, and act. It transforms complex ocean dynamics into actionable knowledge, accessible to all. From real-time forecasts to long-term planning, the EU Digital Twin of the Ocean is already shaping the future. Data becomes insight. Insight becomes action. Welcome to the next wave of ocean intelligence.